All right, so thank you all for coming to class. I'm going to try to record everything we talked about today. However, I have a slight feeling that the sound isn't going to work. I'm going to try to fix that, so hopefully by this afternoon there'll be something, or maybe by tomorrow there'll be something on there for today's lecture. All right, so we have kind of a lot to get through today. So the plan is we're going to review kind of the basics of object-oriented programming. We're going to be going over Program 4, which is due this Friday, and we'll be getting, and last thing is we're going to be getting into today's topic, which is going to be inheritance. So let's see. So the first thing I want to talk about really, and is kind of just stepping back and looking at object-oriented programming as a whole. I'm the kind of guy that I'd like to know the importance of what I'm learning. And I don't think John has really talked about why object-oriented programming is really important. There's a reason why we spend 2 weeks learning about object-oriented programming. Object-oriented programming is important because it's a fundamental idea, it's a fundamental way that we approach a problem in computer science. Very often, if we're given a problem, we first kind of go to object-oriented programming and say, what kind of classes can I make for this problem? What kind of methods for those classes will give me that can I use to solve those problems? All right, if you're a computer science major, which I know there's probably a good chunk of you in here that are a computer science major, in your future computer science classes, you'll pretty much only be using object-oriented programming. Next semester, if you continue in the kind of the path for computer science majors, you'll learn about Java, which is a different programming language, and that Java is all object-oriented programming. All right, so it's important to understand pretty much the basics here of object-oriented programming, just to so that you don't get lost in future classes. And it's important to kind of keep all the skills that we're learning in these 2 weeks in your tool belt here. All right. If you're not a computer science major, which I know there's also a lot of people in here who aren't computer science majors, it's important because it's going to be on the next exam, and I don't actually know what's going to be on the final exam, but I think object-oriented programming is extremely fair game for a question on the final exam. All right, so object-oriented programming is very important here. All right. So let's get into Program 4. Program 4 is due this Friday at 11:59 p.m. That's the last day there before spring break, which kind of sucks. So what I'd recommend is getting started on this today or tomorrow, and you should be able to finish it in, I can't really say, but like under 3 hours, maybe even less than 2 hours even. Okay, and so this is all object-oriented programming for this assignment. You should have all of the tools and knowledge to solve this assignment. What you're learning this week, you don't need this. You don't need that for Program 4. Program 4 is mostly just kind of the basic object-oriented programming methods and classes. All right, so so we'll be working, kind of the topic in this program is Pokemon and Pokedex. And I have a feeling that there's probably some people in here who don't know what Pokemon is or what a Pokedex is, which is a little concerning to me. So Pokemon is this, it's like this series of video games, and I guess there's a TV show and like a trading card for it, but it's kind of well known for their video games. And so Pokemon is kind of like this world where it's inhabited by these monsters or creatures called Pokemon. And so here we got Bulbasaur, which is a Pokemon, and so we have 800 and some Pokemon, and each Pokemon has like a number, a name, a type, and like combat points. Okay? And so a Pokedex is simply just a list of all the Pokemon. All right? In this case, we're not looking at all 800 Pokemon. We're only going to be looking at like the first 30 Pokemon in the Pokedex. All right? So, so for this assignment, we are going to be reading from a text file. You notice that it's a .txt file. It's not a CSV file like we're normally used to working with, but you can still notice that everything in our list is still separated by commas. So we can kind of do something very similar to what we did with the .csv files. So kind of how this is set up is each line in this file is each individual Pokemon. All right, we got Bulbasaur, who's number 1. Name's Bulbasaur. His combat points is 318, and his type is grass and poison. All right, and it follows this format for pretty much every line in the file. You know, we get the number, the name, combat points, and the type. And the type could be just one type, it could be 2 types, or if you're this special Pokemon called Yeet, then there's 8 or 9 types. And it was kind of funny. On Friday when I was talking with John about this program, he was telling me about how he just learned what Yeet is, and he was thinking it's like a dance move or something, and it was just funny hearing him talk about Yeet. All right, so cool. Let's go ahead and take a look at the code that's given to us, and I think I have this open here. All right, so this is kind of the code that's given to you. And I'll make that just a tad bit bigger. All right, I think is that good? Is that too small for anybody? Cool. Okay, so this program is pretty similar to the last program we did in the fact that we kind of have a menu that you have a bunch of different options, and you give the menu 1 or 2, and it does a certain function. So for this, if we take a look at what's going on here in main, we say Pokedex is equal to this function here called create Pokedex, which we pass in our Pokedex text file. And if we jump up here to create Pokedex, you can kind of see this, and since we've worked with files already, you can kind of tell what's going on. It's very similar to what we've done in previous labs and programs. So we open our file, we do a for loop through the entire file, we do our .split line, and then we get the appropriate information from that list. So the number was the first element in that list, the name was the second element in that list, combat points the third, and lastly we have the type of the Pokemon. All right, and so the type of the Pokemon is going to be a list. That's going to start at the 4th element in the list, and will go for the entire length of the list. Okay, and so we say types, which is our list, plus equals PokeList position, which will append everything or add everything to that types list, and then right here we say Pokedex plus equals, and we add a new element to that list, and the element in that list is a new instance of a Pokemon object, right? Can we understand why that's a Pokemon object? So we have this Pokemon word right there that's capitalized. So we know that we're going to need a class called Pokemon, all right? And so our Pokedex, our list called Pokedex, is going to be a list of all of our Pokemon objects, all right? And so we close this, and then we return our Pokedex at the end. All right? And so we also have this another function here called getChoice. This one's not super important for you to understand. You don't really need to use it. All it is just kind of a more advanced way of making sure the input that the user puts in is valid. All right? So you can take a look at that. You might be able to understand what's going on, but not super important. All right? So we have our main function here. Create our Pokedex, and we have a choice variable, and the first thing we do is we print our menu. All right, and that's a function that you'll have to make. print menu is super easy. If you take a look at the sample transcript, we have our print menu right there. So all that the print menu function should do is just print that. Pretty easy. Okay, and so kind of similar to program 3, we check to see what choice is. If choice is 1, then we run our function called print Pokedex. And then, if choice is 2, then we run our lookup by name, lookup by number, and total by type. So if we take a look at the sample transcript and kind of see what we need to do here. If we enter in 1, so if we want to print the Pokedex, we pretty much go through our list, and for each object, we pretty much print out the number, the name, the combat points, and the type. All right, and we'll do that for everything in our Pokedex, or in our list. All right, for our second function, we have print by name. So what's going on there is we get a name of the Pokemon from the user as an input string, and we go through our list and check to see if the name that was given to that function exists in our list. And if it does exist, then we print out the correct information. So we put in Raichu, and Raichu does exist in our Pokedex. It's a name of a Pokemon, so it'll print out all the information for Raichu. 26, Raichu, 45, and the type is electric and psychic. All right? And if we put in the name Raichump for a name, Raichump isn't a Pokemon in our list. It's a fake Pokemon. So then what happens is it should print out there's no Pokemon named Raichump. All right, so that's the second function. The third function is very, very, very similar, except for inputting a name, you put in a Pokemon number. All right, so we put in the number 26, which is Raichu, so it prints out all of Raichu's information right here. All right, so that second function, the third function are very, very similar. In fact, you could pretty much copy and paste and probably just change a couple things. All right, and so if we put in a number that doesn't exist in our Pokedex, then we print out there is no Pokemon number 34 or whatever. All right, menu option 4, so for our fourth function here, is we give it a type. So normal is like a Pokemon type, and we'll go through our Pokedex and count up all the Pokemon that are of type normal. So normal is a type. So so according to our text file, we have 7 Pokemon that contain the type normal. All right, and this fourth function here is pretty similar to the last two. But we got to remember that Pokemon type is a list. All right, so you kind of have to do a little bit more there since it's a list. Cool. And so if we give it a type that doesn't exist, unknown's not a type, we get 0. All right, and the last one is print the average combat points for all the Pokemon. So it pretty much just gets the average combat points of every single Pokemon in the Pokedex. All right, and we've kind of taken the average of a lot of things now in different assignments. So that last one shouldn't be too bad. All right, so if I open up this code here, because there's something I want to check our understanding on. So we have a function here called print Pokedex, and we have a function here called lookup by name, lookup by number, total by type, and average hit points. So we know we need a Pokemon class. All right, my question is, and let's think about this, should those functions go inside of our Pokemon class? No. Why? I don't know.
They're not being called as a class.
Exactly. Yeah, we don't call print Pokedex on an instance of a Pokemon object. We don't call lookup by name on an instance of a Pokemon object. We just straight up call it. Remember that, like in last week's lab, we said president.getName or champ.getName. All right, we called that get name on a specific instance of our contact class. So that was a dead giveaway that we needed those methods inside of our contact class. All right, so for all these functions, they're not going to be inside of our Pokemon class. All right, but within these functions, we're probably going to call a method in our Pokemon class at some point. All right, so I just wanted to just make sure we understand that. So is there anything else? I think that's all I needed to go over for that. Before you submit, just make sure you go through the sample transcript, make sure everything is working correctly. Yeah, and I know I usually do some like help sessions for these programs, and I'd like to do one for program 4 because I think a lot of people came to the last one, and so it tells me that people are utilizing them and they're helpful. And so I'd like to do a help session for program 4. I just don't know when yet because this week's kind of crazy for me, and Friday's the week or the day right before spring break, and I was hoping on Friday I could just get the heck out of Bozeman and get on with my spring break. So I don't know yet, and I will, if I do have a help session for program 4, I'll be sure to let you know via D2L announcement. Okay, so program 4. Is there any questions or concerns for program 4? You in the front.
So, if we don't put all of these functions like print, text, look up by name, all of those don't go in the class? What are we using the class for?
So, right. So, I don't want to give it away, really. But, so, our Pokemon class is how we're going to create a Pokemon object. And we know that we're going to have a name, a combat points, type, and number in any particular order. All right? And so, if we have a list of objects, what we could do is we could iterate through that list, all right? And then we could call certain methods to, we could say list item dot get name or list item dot get number, and that's kind of the purpose here for our Pokemon classes, for those get methods here. All right. And one more thing I'll mention as well. On Friday or Wednesday, I think, we talked about the __str kind of special method for object-oriented programming. You don't need that in this program. You can do it without it, but you can totally use it. There's totally an application for it here, but it's not necessary. All right. So did that answer your question? Cool. Yeah. Yeah, so so types is going to be a list, and it can be a list of length 1, because it could be one type, or it could be a list of 8 elements or whatever for yeet. And so if we wanted to kind of get this sample transcript here, and we wanted to turn our list into, the type 1 and type 2, kind of like that, there's kind of a lot of different ways you can do it. You could kind of iterate through the list and kind of concatenate onto one long string, or you could look into the .join method. So yeah, there's kind of some different ways you can do that. Did that answer your question?
Yeah.
Cool. Any other questions about program 4? Sweet. All right, so yeah, just make sure you get that finished and submitted by March 15th, 11:59 p.m. All right, so I'm going to close this, and we're going to go ahead and get started on today's topic. But quickly, we're kind of going to review. So at this point, you should kind of feel comfortable working with the basics of object-oriented programming. You should be comfortable with what a class is, what a constructor is, and kind of the basic get methods and set methods for a class. All right, so let's kind of create an example here that we'll be using for kind of the rest of this lecture. So suppose we want to use object-oriented programming to model all the different kind of employees at a company. All right, so our classes are going to represent the different kinds of employees at a company. So one type of employee we could have is we could have an accountant. All right? And I gotta pull up something else here. Okay, and so first thing we usually always do is we make our constructor here. And suppose we're always going to pass in self. And suppose for the accountant we give it a name, a employee ID number, a salary, and I don't know, a CPA ID, so their certified public accountant ID number. I don't know if that's actually a thing. I'm just kind of pulling it out. All right. Maybe. There's probably some accounting majors in here who are probably pissed at me. So, we'll say self.name is equal to name, self.employee ID, which I'm going to be abbreviating saying EMP ID, is equal to EMP ID, self.salary is equal to salary, and self.CPA ID is equal to CPA ID. All right, so this is pretty straightforward so far. I'm not trying to trick you. You should probably understand what's kind of going on so far. So all we have right now is our accounting class and our constructor, which will actually build an instance of an accountant object. All right, so now we can come down here and we can create a new instance of our accountant class. All right, and we got to give it a name, an employee ID, a salary, and a CPA ID. So let's suppose the name is our good friend Kevin Malone. The employee ID will be 123. The salary will be 40,000, and the CPA ID is I don't know how it is, A7BF2. All right. So we've created a new instance of an accountant object. So what we can do now is if we wanted to maybe just print out the name of the accountant object we created, we can say print employee1 dot get name, right? Our reader methods are what we use to get a certain value of an object. And so get name isn't defined, and so we got to do it in our accountant class because we call it on an instance of an accountant object. So we'll say define get name, and we need self in there, right? Because self will always get passed in. And so pretty much all we're going to do for our get methods is probably just going to return something. In this case, we just want the name. So we'll just say return name. Are we good? We're good? Let's take a look. All right. We're not good, actually. We're in trouble. We're getting an error saying name is not defined. Anybody know why? Yeah. Is that what you were going to say? Yeah. We're missing self. All right? And this is really important. If we just say return name, name on its own doesn't really mean anything. Doesn't have a value. All it is just a attribute for a generic accountant object. All right? So that's why we have to say self, because self.name is a specific name of an object. All right? Do we understand what self is? This is important. I know we touched on this on Friday, but this is important. All right? So self refers to the specific instance of the object we're calling get name on. So we call get name here on employee on EMP1 or employee 1. So self is going to be employee 1. So kind of what it looks like is we're passing in employee 1 for self, and we're returning employee 1.name. Employee 1.name is Kevin Malone. All right? So self is important. It's important to understand what it's actually doing. Self represents the specific object we're calling the method on. So now, if you run this, get our good friend Kevin Malone. Cool. And so, of course, we could have the rest of our reader methods is equal to employee ID. Whoa. Self. We'll say return self. Wow. Self dot CPA ID. I'm going to go ahead and just copy and paste just this for all of our attributes here. Okay, so let's see, that looks good for me. We just have 4 different reader methods for our accountant class. So now we can just say emp1.getSalary or getCPID, and it will do it for us. All right. Any questions so far? This is not trying to confuse you yet. We're just making a very basic class for an accountant. Cool. So kind of so far, we've really only been kind of working only with one class. I think on Friday we kind of got into the realm of having 2 different classes. Like we had like a deck class and a card class. And you know, it's actually very common to have more than one class. We might have many different things we want to model, and so we could have many different classes. We could have as many classes as we want. So let's go ahead and continue with this. Let's think of another kind of employee we could have at a company. Let's say we could have a developer. And so we'll need our constructor. And so we'll say self. Every single employee will have a name, an employee ID number, a salary. A developer doesn't have a CPA ID. I mean, it's possible a developer could also be an accountant, but that's kind of strange. And so suppose our developer also has a language, which represents the programming language they can use. All right? So I'm going to do some copy and pasting here because it's pretty much the exact same, except down here we need to create the language. All right, and you know, we could totally, if we want our reader methods, we can copy and paste them over again. And we'll say here, we'll say get language, and we'll return self.language. Cool. I think this developer class is looking good. So now what we can do is we can create a new instance of our developer class. And so for the name, we'll give it our supreme overlord here, John Paxton. Number, employee ID number will be 456, and his salary will be $80,000 because a computer science degree gets you a lot of money. All right, and his language is Python. Cool. And so we can totally, now we can just say print employee2.getName. We could say employee2.getLanguage. If we run this, please don't. Okay, awesome. Yep. So we're getting the name. I'm like so afraid that I'm going to get in there. That's like my worst nightmare here. Cool. So we're getting Kevin Malone. We're getting John Paxton, which is the name, and the language, all right? And so, and you can see we did all that right there. All right? Nothing tricky yet. So, let's create another class. And so, suppose we got a sales person. All right? And for our constructor, we're going to pass in self, we're going to pass in name again, employee ID again, salary, and suppose we want to keep track of like the commission a salesperson has. I think that's a thing. We'll do the exact same thing is equal to name, self dot employee ID is equal to employee ID, self dot salary is equal to salary, and self dot commission is equal to commission. All right, our constructor looks good, and now we could totally just copy and paste all of those reader methods again. And if you're thinking that this is getting kind of redundant, it is. And that's kind of the point I'm going for. This is getting pretty redundant, all right? We have all of these classes, and every one of these classes, they all have the name, employee ID, salary, and all the reader methods for those attributes. So this brings us into kind of today's topic, which is inheritance. All right, and so inheritance, as just a basic definition, is it allows a class to inherit the instance fields or the attributes as well as the methods of another class. All right, and we can totally use inheritance here. All right, and this might be a little confusing at first, but just kind of stick with me here. So if we look at our classes here, we realize that accountant, developer, and the salesperson, they all share a name, employee ID, and salary. That's something that every single employee at this company is going to have. And we know that all those, the get name, get employee ID, and get salary, those methods are going to exist for every single employee. All right? And so what we can do here is we can use inheritance, and we can just create a class called employee, right? This is a generic, you can think of it as just kind of a generic employee class. So we'll have our init, our constructor for our generic employee class. And so remember that every employee will have a name, employee ID, and our salary. And we'll do all this over again, hopefully for the last time. All right, and I'm just going to go ahead and copy and paste the correct reader methods. And cool. So we have a generic employee class now. So what we can do now is we can tell accountant to inherit the attributes and the methods of an employee class. All right? So if we inherit from the employee class, then we don't have to worry about defining the shared kind of attributes here for the accountant class. All right? So stick with me here. We'll make it through this. So to denote that we're inheriting from a class, what we can do is we can come up here and we can give it the class name of where we want to inherit from. All right? So in our class declaration, we can put in parentheses the name of the class we're inheriting from. So what this is saying is that our accounting class is going to inherit the attributes and the methods of our generic employee class. Some more terminology is accountant is a subclass of employee class. Also, employee is a superclass of the accounting class. So, cool. So now that we're inheriting from accountant, we don't have to worry about self.name, self.salary, self.employee ID, because it's defined in the class we're inheriting from. All right, and since we're inheriting from that, we're going to get all those attributes. So, if we go ahead and modify our constructor now, all we have now is self.cpaid is equal to cpaid. But when if we create an instance of an accountant object, so we have Kevin Malone. If we wanted to create another accountant for Angela Martin, we still need to create the name, employee ID, and the salary for an accountant. All right, but that's now going on in our employee constructor. So what we're going to do is we're going to call our employee constructor, and we're going to pass in self, name, employee ID, and salary. All right, cool. And also we have these get methods in our accountant class, but we don't need them anymore because they're in the class we're going to be inheriting from. They're in our superclass, so we can actually just get rid of these. All right, so all we have left is our get CPID, because CPID is kind of like a unique attribute for an accountant. All right, awesome. And so likewise, we can do very similar down here. We're going to call our employee class, and forgot the most important part here. We need to tell the developer class that we're going to be inheriting from employee, which if you remember, we do that in our class declaration. Cool. And then also we can go ahead and get rid of all those methods. All right, so you can kind of see already, just by using inheritance, we've removed a lot of the redundancy of our classes here. We looked at what attributes and methods are shared across all of our classes, and we just took that and made it its own class. All right, and that class is going to get inherited by all of the specific employee classes. All right, and we're going to go ahead and get rid of salesperson. We're only going to be looking at accountant and developer here. And so let's go ahead and run this and make sure we're not getting any errors. All right, we're still getting the same output. This is good. But let's take a look at what's going on here. We say print emp1.getName. All right, so emp1 is an accountant object. All right, and since we're calling getName on an accountant object, then getName should be inside of our accountant class. But if you look up here, we don't have a getName method anymore, but it still works. We still got the same output. We get the same output because we inherit from the employee class, right? And so we have access now to this getName up here. All right. So getName method isn't defined in our accounting class anymore, but it doesn't matter because we have access to it from our inheritance. Okay? And similar things going on down here. getName isn't defined in our developer class, but we can still call it because we inherit from the employee class, which is where that function exists. Okay? Any questions so far? Okay. I'm hoping this kind of makes sense here. Cool. So, all right, so let's go ahead and make another class here. Okay? And so we'll call this developer intern, and we are going to inherit. We're actually going to inherit from developer. All right? And for our constructor, we'll say self, employee has the name, their employee ID, the salary. Developer intern is also going to have a language, but it's also going to have the college or university they go to. All right? And so, since we're inheriting from our developer class, we need to call our developer constructor. And so we'll say developer dot underscore init, and we're going to pass in self, employee ID, salary, and language, right? Because that's what the developer class is expecting up here. All right, and last but not least, we got to handle the college. It's equal to college. And we have our developer intern class done. I won't worry about any of the get methods there for that. So let's go ahead and create a new instance of our developer intern class. All right, and we got to give it a name. So I'll give it myself, and my employee ID number is 777. My salary is 10,000, which is pretty generous. I also know Python because it's the best language. And for college or the school, we'll give it MSU. Okay, so it created a new instance of my developer intern class. So now let's go ahead and print out some of the information for it. So the first thing I'm going to do is I'm just going to print out nothing, just so we can kind of see where it starts here. And we'll print out employee3.getName, print employee3.getLanguage, and we'll print employee3. We'll do get college, and I'll have to make that up here. All right, and oh god, let's see, where was this going on at? I forgot to put in name. All right, thank you. There we go. So let's see. We can see there that we're printing out the name of our developer intern, the language, and the school. All right, and language isn't defined in our developer intern class. Neither is name. All right, but we inherit from our developer class, right? And so that will give us the language, but our developer class inherits from employee. All right, so developer intern's actually kind of inheriting from employee also. All right, any questions so far? Okay, so what I'm going to do now is often when we have a lot of classes, we have a lot of inheritance going, it can get pretty confusing about kind of the chain of inheritance that could be going on. So what we do is we create these diagrams, and they're called inheritance hierarchy diagrams, and allows us to kind of illustrate and kind of lay out kind of the structure of our classes and of our code. And this is something that is very common for computer science. Software engineers do this all the time. So what we can say is we have a class here. We have our employee class, right? And we denote that by giving its own special box. So we also had a accountant class. And so accountant class inherited from our employee class. So to denote that, we're going to draw an arrow from our accountant class to our employee class. All right. Likewise, for our developer class, we inherited from our employee class also. Right? And lastly, we had our developer intern class. My handwriting sucks. And so our developer intern class inherited from our developer class. So this is kind of like a diagram of kind of how the inheritance is working here. So at the top, we have employee, which is our generic object. So it's kind of at the top of the tree. And kind of the more we go down the tree, the more specific we get in our classes. All right? First we go employee, then we go developer, which is more specific, and developer intern, which is even more specific. All right? So I'm quickly running out of time here. So if we swap back to our code here, is there any questions about what's going on here? Yes?
So when it comes to like the development intern, in that sense, if let's say they didn't have a salary, some companies don't pay their intern salary.
Sure.
Can you still use that employee hierarchy through development and get by with it running properly?
Yes. So, what you could do is, you could specify, 0 right there, or you could say any number if we went back to 10,000. What we could do also is inside of our developer intern constructor, we could say self.salary, and we just set it equal to 0. We just kind of hard code that, all right? And that will override whatever the employee constructor gave us. So there is a way. We just kind of override it, or change it to whatever we want to change. Yeah, and I want to talk more about that, but I don't have time. So maybe John will talk about that on Wednesday. Any other questions about what's going on here? I don't think so. So, all right, that's all I got for today, really. What I'd recommend is before class on Wednesday is take a look at the Dungeons and Dragons Python file, which also uses inheritance. So kind of look at this and try to understand what's going on, and try to draw out one of those diagrams that we made similar to our employee class. All right? Awesome. Have a good rest of your day. If you have any questions, let me know.